Welcome to Scientific Software Horizons, the podcast where curious minds in science and technology come together to explore what's next for scientific software. Each episode brings you into the conversation with cross-disciplinary experts and community visionaries as we dig into the opportunities, challenges, breakthroughs, and emerging solutions shaping the future of scientific software. From HPC to AI to quantum, we're diving into the technical leaps and the human stories behind them, the people, the practices, and the evolving ecosystem driving tomorrow's discovery.
Let me start off with a big welcome to all of our listeners. Our guest today is one of the most recognizable and respected voices in the global high-performance computing community. For nearly 2 decades, he's been at the forefront of GPU computing, distributed AI training, and large-scale scientific computing. In 2009, he was a member of the team that received the prestigious Gordon Bell Prize for groundbreaking work that helped demonstrate the transformative potential of GPU-accelerated computing, and at a time when the field was still in its infancy. Rio Yokota is a professor at the Supercomputing Research Center within the Institute of Integrated Research at the Institute of Science in Tokyo. He also leads the AI for Science Foundation Model Research Team at the RIKEN Center for Computational Science, where his work spans high-performance computing, machine learning, and numerical linear algebra. Throughout his career, Rio has played a leading role in advancing large-scale AI and distributed training on some of Japan's most important computing systems, including ABCI, the AI Bridging Cloud Infrastructure operated by AIST, Tsubame, one of the world's pioneering GPU-accelerated academic supercomputers, and Fugaku, the internationally renowned system at RIKEN, named in honor of Mount Fuji. Rio's contributions also extend well beyond the machine room. Rio is a co-developer of the Japanese large language models Swallow and LLM-JP, and he's helped foster international collaboration through initiatives such as the Accelerated Data Analytics and Computing Institute, or ADAC as we know it, and the Trillion Parameter Consortium. From pioneering GPU computing to advancing foundation models for science, Rio has consistently worked at the intersection of the technologies shaping the future of computing. It is indeed our pleasure to welcome Rio Yokota to the podcast. And to get us started, here's our co-host, Mike Heroux.
Well, I'm very excited today to have Rio Yokota join the Scientific Software Horizons podcast. Rio, for listeners who may not know your work, could you please briefly describe your role in the Japanese HPC AI ecosystem and the types of problems you focus on?
Yeah, thanks for having me, Mike. So I'm a professor at the Institute of Science Tokyo, and I work on fast and scalable algorithms on GPUs, such as the fast multiple method for n-body problems, and also their algebraic alternatives like structured low-rank matrices. I also more recently work on fast and scalable training of large language models. I've been involved in training Japanese LLMs like Swallow and LLM-JP.
How would you describe Japan's current national strategy around HPC and AI, particularly from a software perspective?
One big change that's happening now is we are transitioning from Fugaku to Fugaku Next, which is scheduled to be deployed in 2030. And Fugaku is a CPU-only machine, and Fugaku Next will be a GPU CPU machine. So we need to prepare for this, and I think that's one of the major developments in software in Japan at the moment.
I would guess one big part of this is the switch from CPU only to CPU plus GPU means a pretty disruptive change in the design of applications. What are some of the strategies you're using, for example, for programming models and those kinds of activities?
So I think it's a layered approach. So at the entry level, OpenACC directives are a very easy way to port something to GPUs. When you aim for more performance and portability, we do adopt frameworks like Cocos. And also some people have been programming in CUDA, like myself. I've been a CUDA programmer for maybe 15 years now. And so there's different layers that we are attacking this from.
Historically, I think quite a few Japanese codes were written in Fortran. Is that a true statement?
Yes, upon conducting this effort to transition from CPU-only codes to GPU-CPU codes, we have done a survey to see which codes are in what language, are they GPU capable, and we've found that a majority of codes are still these legacy Fortran codes. And some of them have parts of it that call GPU libraries, but we have a majority of codes that are still just Fortran codes running on CPUs.
Do you see this changing? Do you see codes transitioning to other programming languages, or perhaps you have other strategies for bringing the Fortran codes so that they will work on accelerators?
Yes, one approach is because now we have these generative AI tools that makes it easier for us to actually do this transition. I think that's one of the key significant things that are happening at the moment. So I think in the US, for the ECP project, a large part of that was transitioning and preparing codes for the GPU machines that were becoming available at the time. But they didn't have this kind of generative AI capability at the time. We are, in a sense, fortunate that this transition into GPUs is happening at the time when we have these generative AI tools. So it's very interesting to see what's going to come out of this.
So yeah, the exascale computing project, also called ECP, was an effort that's similar to what you're going through, but we did not have the same AI tools that you are able to benefit from. It'll be very interesting for us to observe and see how your experiences are improved and different. So going forward, so moving to accelerators, GPUs, away from CPU only, lines you up with efforts within the U.S. and some European efforts as well. Do you see this as beneficial? And I would imagine so. We share now a more common hardware architecture, software architecture. What are some ways that this better alignment or consistent alignment across international communities could help everybody?
In the past, the hardware on Japanese supercomputers was very unique. If you look at the Earth Simulator or K-Computer or Fugaku, they all had their unique hardware architectures, and also along with that, a very unique compiler and software ecosystem. Now that we are transitioning to more standard hardware and the software that sits on top of that, we are able to more tightly integrate with the global ecosystem, the software ecosystem. And so I view this as a positive thing. And the general trend in Japanese software is moving in that direction.
As you know, GPUs are also primarily designed for AI workloads. You'd already mentioned accelerating application development and migration to GPUs using AI tools. What about other aspects of AI, in particular AI for science? So what are some of the activities you see going on there in Japan?
So in Japan, there's a strong push towards AI for science. There are multiple efforts that are trying to align with the US Genesis mission and also the AI for science efforts in Europe. We are looking at science domains, and how each domain can benefit from AI, both in terms of using surrogates to replace parts of our simulations, and also using AI in the outer loop as an AI scientist to create workflows and, along with the traditional mod sim, accelerate science as a whole.
So it sounds like bringing AI for science in also includes, traditional modeling and simulation. You mentioned surrogates, for example. I imagine digital twins would be a part of that activity, and then having AI, drive the scientific process. Are there other ways that you see, the AI and mod connection intertwining?
Yes, there are many different ways AI can be combined with traditional mod sim. So even for surrogates, this could mean many different things. So from the AI point of view, the simulations being able to generate data on the fly, and from the simulation point of view, the AI being able to steer the simulation to configurations, to explore new configurations. From both of these sides, I think there are many possibilities of how to combine these.
From a software ecosystem perspective, what are the hardest problems Japan is trying to solve right now?
One of the main issues is that traditional HPC software ecosystems sit on this kind of batch scheduling on our on our big supercomputers. And while AI workloads are more elastic, traditionally using cloud resources. For example, in HPC, we may use Slurm to schedule our jobs or any other job scheduler. In AI, people use Kubernetes, and we may want to have a software stack where Kubernetes is at the bottom and Slurm is one of the things that sits on top of it. We are now considering this type of configuration.
Related, how are you approaching software sustainability for scientific software in particular?
This is one of the issues that becomes very interesting in light of the current developments in AI. The value of legacy software may be diminishing, or it may not. This is yet to be seen. But for sure, there's a huge acceleration in actual software development aided by AI. And this is not just about the writing of the code. It could be about debugging or restructuring of the code or translating to a different language. All of these can be accelerated significantly with AI. At the moment, it's a little bit clumsy, but at the rate at which it's improving, it's very interesting to keep an eye out on what will be capable next year or in the next 5 years.
Do you see ways to collaborate more deeply with, say, U.S. and European efforts now that there are more similarities in the hardware-software ecosystem?
Yes, there are many opportunities for collaboration, especially as you mentioned, the hardware in Japanese supercomputers is now adopting commercial hardware that is common to the US and Europe. For example, AMD or NVIDIA GPUs. And Fugaku Next is planned to have NVIDIA GPUs. So on that common hardware will sit common software ecosystem. So we should potentially be able to have common repositories. Maybe this could be SPAC or some other package manager, and have something that is shareable across Japan, US, and Europe.
Onto a different topic. What is Japan doing to build the next generation workforce for HPC and AI?
As a professor at a university, I have many students that are interested in HPC. They are more interested in AI these days. One of the challenges we have is all this talent after they graduate, instead of going to academia, they tend to go to these frontier AI companies. A lot of my students do. And so even though we train the students, because there is a huge demand for systems people and software infrastructure people in the AI companies, they tend to recruit very aggressively our HPC talent. So how to keep them in HPC, in academia, or at labs is a challenge for us.
I think we share those experiences here in the United States. Very similar dynamics. So it is quite a challenge. I guess we have the excitement of the mission, perhaps, but yeah, it's definitely a real challenge. Yeah. So for the new people you do have coming or staying in the field for, say, AI for science, what are some of the shifts in skill sets? You're teaching, for example. Are you modifying your curriculum, towards a direction that is, more AI centered or more balanced between modeling and simulation and AI?
So I teach a graduate course on high performance scientific computing. Traditionally, it would start from things like OpenMP, MPI, and CUDA, and then cover things like parallel debuggers and profilers. And then gradually, I started introducing containers, how to use Docker, and things like Singularity that runs on our supercomputer Tsubame. And now I'm introducing more and more AI components into the course. I started with introduction to how to train these neural networks, and then now I'm introducing how to code using AI. And I sort of keep the original part of teaching OpenMP, MPI, and CUDA in these basic programming languages, but at the same time, later in the course, I introduce how to make that easier. But I think it's important to have the basic knowledge before they start vibe coding.
Very good. Vibe coding. Yes. Fun term. So I've asked you a lot of very specific questions. I'll ask a more general question and get your response. What's the important aspect of Japan's HPC and AI efforts that we haven't talked about, but should?
I think there are certain parts in the Japanese community, Japanese HPC and AI community, that are somewhat unique. For example, in the US, there's a very strong AI industry. In Japan, there's not so much. I mean, it's not as strong as the US industry, AI industry. And so this creates a slightly different dynamic. So there are a bunch of government-funded projects in AI in Japan, for example, training these large language models. And those efforts seem to produce more capable models than the ones in the Japanese industry. And so this different dynamics creates different demands in the human resources and also computational resources, the allocation of the computational resources. One challenge that we face is the lack of computational resources. We have very few GPUs compared to the US, and this is not just in the labs. It's, the US has many GPUs in the industry side, and we are completely dwarfed now by the compute capability that US possesses. This did not used to be the case. I mean, if you remember, Japanese supercomputers used to be, on the top five, on the top of the top 500. But now we need to deal with this situation where we are heavily disadvantaged in terms of the quantity of computational resources.
Similarly, are there misconceptions that you often hear about Japanese HPC AI from outside of Japan that you would like to clear up?
Well, fortunately, the people I talk to mostly understand the Japanese HPC and AI situation quite accurately. I occasionally hear things about, the Japanese because Fugaku is a CPU-only machine, that we are not capable of doing AI because that requires a lot of GPUs. We do have a lot of GPU resources on the other machines. So, for example, I use Tsubame. It's one of the first supercomputers that actually adopted GPUs back in, I think, around 2008. And we still have many GPUs. We are one of the strongest GPU centers for a university. And so this gives us an opportunity to train our students. All of our students have access to, this Tsubame supercomputer with thousands of GPUs. So I think the misconception that because Fugaku is the visible machine and that it's only CPUs, doesn't mean we don't have any GPUs at all. So I would like to clarify that.
What are you personally most excited about right now in your work?
So as I've been saying, the thing that most excites me is the possibility of AI. And it has so many different possibilities. It could greatly accelerate our coding capability. And at the time when we need to transition from CPU code to GPU code, this can be a huge, huge benefit for us. I think we are doing this transition at the right time. At the same time, I also work on AI, training AI models. And the capability of open models is another thing that interests me. These open weight models are somehow lagging behind the closed frontier AI models. But if you look at the rate of improvement, it's not like the rate is slower, right? So if you follow the trend, even though they're lagging behind, we will have open models that will be very capable in the future. And I think this is very powerful, that an open variant of what we view as cutting edge technology will become available, in maybe half a year or 1 year from now. And this gives possibilities for many people to have access to this technology. And so this would create a positive spiral of more people being able to have this capability, and these people will go on and develop the new capabilities of the future. So I view AI technology both in terms of using it to accelerate science and also accelerating the development of AI itself to be a very exciting thing to keep an eye out in the future.
Looking ahead, say 5 to 10 years, what would success look like for Japan and for the global scientific software community?
I really hope we will be able to adopt this rapidly evolving AI technology in our software development. Although I'm not entirely sure what kind of capabilities that will be available, I'm very hopeful that this technology will drastically change the way we approach software. Some parts of the software will become a commodity. Instead of treating software as something that has our legacy software that has high value, we would be able to treat it like maybe assembly code that we can somehow generate from natural language, and this would change the way we approach software. I think during that transition phase, verifying the correctness and also reproducibility is the key. I would really like to work on this aspect to assure that this transition happens in a reliable way.
Rio, thank you very much for joining us on the Scientific Software Horizons podcast. We really appreciate your comments and thoughtful responses to our questions.
Yeah, thank you, Mike. I really enjoyed our conversation today on the Scientific Software Horizons podcast.